So welcome to this presentation. Today we'll be discussing the solubility and the precipitation equilibria. Let's start on question number 9 because we have ended question number 8 last time. Question number 9 is saying what is the maximum concentration of chromate ion that is allowed before silver chromate will precipitate if the silver ion concentration is 7.8 times 10 power negative 4 molar. They are giving the KSP of silver chromate, which is equal to 1.1 times 10 power negative 12. So here we have the concentration of the silver ion, which is equal to 7.8 times 10 power negative 4. Now they're asking the concentration of the chromate. So let's see the answer. We have the silver chromate, which dissociate to give 2 more of the silver ion plus the chromate ion. If you are going to write the KSP, which is the solubility product constant, will be equal to the concentration of the silver raised to the power of 2, because here we have 2 moles times the concentration of the chromate. So we have the concentration of the silver that was given. So the concentration of the silver was given, which is equal to 7.8 times 10 power negative 4 molar. Then we can, the KSP was also given, so we can then use the concentration of the silver. Then we replace the concentration of the silver raised to the power of 2. Then we replace the concentration of the chromate as the unknown. The KSP was given. We have a KSP which is equal to 1.1 times 10 power negative 12. Then we can determine the concentration of the chromate as S. Then we get 1.8 times 10 power negative 6 molar as the concentration of the chromate. So the answer is the 1.8 times the 10 power negative 6 molar. Let's quickly rush to question number 10. Question number 10 is saying 250 milliliter of 2.2 of 2 times 10 power negative 5 ml of silver nitrate was mixed with 250 milliliter of 2 times 10 power negative 4 molar of sodium iodide. Then they're asking what is the name and the mass of the precipitate. So here they have 2 compound, silver nitrate, which is mixed with sodium iodide. Then they're asking what is the name of the precipitate, and then they're asking the mass of the precipitate. Here we need to rely on the solubility product rules so that we can know the different compound and how they are dissolved into the aqueous phase. In this case, we are going to rely on the solubility rules. Solubility rules, the first solubility rule is saying the salt formed with group 1 cation and ammonia and ammonium cation are soluble. So this includes these salt formed with these ions. That means they are soluble. There are some exceptions for certain lithium salt. Then the rule says the acetate, nitrate, perchlorate are soluble. Bromide, chloride, and iodide are soluble, except for this one acetate, silver, lead, and the mercury. Remember here in this compound you have the silver nitrate, so we can see that silver also, if it is combined with this ion, it is not going to be soluble. So then we have also the combination of here the iodine, so they are saying acetate, nitrate, and the perchlorate are soluble. Bromide, chloride, iodine, so that means you have the silver iodine, which is not so soluble. Silver compound are insoluble, so except the silver nitrate and silver acetate. Sulfate are soluble except for this one. So then there's, depending on the solubility rules, then you can know if the compound is soluble or not. So let's do the reaction and see whether our compound is soluble. So now we need to have the reaction where we have silver nitrate plus sodium iodide, which give the silver iodide. So we can see that here we are going to have the this insoluble compound from the solubility rules. So now they are saying what is the name and the mass of the precipitate. So here we need to determine the mass of the precipitate, but we don't have the KSP. That means here we consider that the reaction is going to compression. So here we are not going to consider that the reaction as in equilibrium, but we need to consider the reaction is going to compression. So here no equilibrium constant was given, so we assume that the reaction goes to compression. Only the reactant is going to give the product, and then we need to check which one is the limiting reactant between this one and this one, depending on the moles which are reacted. If we are going to check for the mole of silver nitrate, we get 5 times 10 power negative 6 moles. That is equal to the concentration times the volume. You get the number of mole. We calculate the mole of sodium iodide. We get 5 times 10 power negative 5 moles. So we can see that the mole of silver nitrate are very small as compared to the moles of sodium iodide. So here we consider that the silver nitrate is the limiting reactant and is the one which is going to be detecting the concentration of the solid which is going to be formed. That means from 1 mole of silver nitrate, it will produce 1 mole of silver iodine. That means the mole of silver nitrate will be equal to the mole of silver iodine, because this silver nitrate is the limiting reactant. So we need to rely on its concentration to predict the product which is going to be formed. So then you have the mole of silver, so iodine, which is equal to mole of silver nitrate, and is equal to 5 times 10 power negative 6. So once we have the moles of solid which is going to be formed, then we can calculate the mass. So we have the molar mass of silver iodine, which is equal to 237.77 milligrams per mole. Of course, this molar mass, you get it from the periodic table by adding the molar mass of the silver plus the molar mass of the iodine. Then by getting the molar mass, taking the molar mass times the number of mole, because the molar mass is the mole of one, the mass of 1 mole. Then if you multiply with the number of mole, then we get the mass. So here we will get 1.19 milligram as the mass of the precipitate. So question number 11. Question number 11 is saying what is the mass of the precipitate formed when 50 milliliter of 16.9% weight per volume solution of silver nitrate is mixed with 50 milliliter of 5.8 weight per weight sodium chloride solution. Here also we need to get the what's the mass of the precipitate, but we have the silver nitrate and we have the sodium chloride which are going to be formed. Then we need to rely on the concept of the solubility rule so that we can predict which compound is going to be insoluble depending on the solubility rule. So here another thing that we need to understand is that here we have 16.9% weight per volume. That means we have 16.9 gram per 100 milliliter of volume. Then if we can multiply the volume of the solution, then we can get the mass of the sodium nitrate. We also determine the mass of sodium chloride by taking, if you have 5.8% weight per volume, that means you have 5.8 gram per 100 ml of sodium chloride. So here also, if we take 5.8 gram per 100 ml, if we multiply with 50 ml, then you get the gram of or the mass of sodium chloride. So let's do the reaction. So after determining the mass, so we have multiplied, then we get the weight. That means 16.9% weight by volume is equal to 16.9 gram over 100 ml. Then we get the mass. After getting the mass, we can get the mole of silver nitrate by taking the mass dividing with the molar mass. Again, also we can determine the concentration and the mass of the sodium chloride. We get 2.9. After getting the moles of sodium chloride and the mole of silver nitrate, then we see they are equal. So here we don't need to determine the limiting reactant because they are equal. So anyone can predict the product. That means either the product which is going to be formed will be equal to the mole of silver nitrate or mole of sodium chloride, which is equal to 0.05 mol. So then from the solubility rules, we know that this compound is the one which is going to be a precipitate, which is going to be formed, and we determine the mass of this precipitate. So we have the mole of the precipitate, which is equal to 0.05 moles. Then to get the mass of the precipitate, we take the moles times the molar mass. Then we get the mass very easy. Let's go to question number 12. Question number 12. Let's see what they ask in question number 12. They are asking if the precipitate is going to be formed after mixing 34 milliliter of 8.8 times 10 power negative 3 molar of lead, molarity of lead nitrate, if it is mixed with 79 milliliter of 3.2 times 10 power negative 3 molar of sodium iodide. They are giving Ki-sp of lead iodide. So if you have the Ki-sp, that means here we have the equilibrium constant, then you have the equilibrium. In this case, then we need to check whether the ionic product that we have is higher than the Ki-sp, or if it is less than the Ki-sp. So that means here we need to check the ionic product, the Ki-sp of lead iodide that was given. So that means we need to check what will be the ionic product between lead and the iodate. Then after having the ionic product, you compare it with the Ki-sp that was given. Of course, in order to get the ionic product, you should be getting the moles and the concentration of the lead, and then the moles of the concentration of the iodate from this one after mixing the two. Because here we can have the moles. Here we can get the moles before mixing, the mole of lead and the mole of nitrate. From this information also, we can get the moles of sodium and the moles of iodide before mixing. Then after mixing, then to determine the concentration after mixing, then we divide the total volume. What will be the total volume? Here we'll be having 34 milliliter plus 79 milliliter, so that we get the total volume. That means the ions that we are going to determine the ionic product, they will be in a combined volume. So that means you need to calculate the concentration in the total volume. Concentration for lead in the total volume and the concentration of iodide in the total volume. So let's first see here we have the equilibrium, so we don't use the concept of limiting reactant. But before, let's find the number of moles of lead and the number of moles of iodate before mixing. So mole of lead before mixing, we take the concentration times the volume. So that means we take 8.8 times 10 power negative 3 molar of lead nitrate. Then we multiply with the volume. So we convert the volume into liter. Then we get this moles. That means we have the lead nitrate. That means this the mole of lead that we have, and also the moles of nitrate is also equal to the mole of lead. So we also determine the mole of iodate. So the mole of iodate before mixing will be equal to the mole of sodium iodate, because the dissociation it will be 1:1. It will give 1 mole of sodium and 1 mole of iodate. So then we also take the 3.2 times 10 power negative 3 molar of sodium iodate. Then we multiply with the volume so that we get the moles. So that means we have now the moles of iodate before mixing and the moles of lead before mixing. Then we can determine their concentration after mixing. That means concentration after mixing, we consider the total volume. Concentration of lead after mixing, then we get the moles of lead, which is equal to this one, dividing with the total concentration. So we have changed the total volume. We have changed the volume into liter. The total volume, that means 34 plus 79. If you convert to liter, you get 0.113 liter. Then we get this molarity. Then we get the concentration of iodate by taking the moles of iodate dividing with the total volume. Then we get the concentration. After getting the concentration of lead and the concentration of iodate, then we multiply them to get the ionic product. So we know that this will be the reaction. We have lead iodate, so you can see we have lead, and then it will, the association of this one will give 1 lead and 2 more of iodate. So then the ionic product will be equal to concentration of lead times the concentration of iodate raised to the power of 2. This 2 comes from the dissociation of this one, because it will be dissociated to give 2 more of iodate. So then we replace the values and then we get 1.3 times 10 power negative 8 mole as ionic product. Now, to know whether a precipitate is going to be formed, we need to compare the ionic product with the Chi-Sp which was given, and we will see that the 1.3 times 10 power negative 3, which is the ionic product, is higher than 3.68 times 10 power negative 13, which is the Chi-Sp, and then in this case we conclude that the precipitate is going to be formed. Because the ionic product is higher than the Chi-Sp, therefore a precipitate is going to be formed. If the ionic product is less than the Chi-Sp, that means we don't form a precipitate. If they are equal, if the ionic product is equal to the Chi-Sp, in that case, we are at the equilibrium. That was question number 12. So let's move to question number 13. Question number 13 is saying we have a solution of 2 times 10 power negative 3 molar of lead nitrate and a solution of 2 times negative 3 molar of sodium sulfate. So here we have two solutions, lead nitrate and sodium sulfate. We have their concentration. Identify the ion that are present in each solution and calculate their concentration. So here the ion which is present here, you have lead and nitrate, so they will be having equal concentration. Lead nitrate, so we need to check the formula. The nitrate is negative, so that means lead will be equal to 2 times 10 power negative 3, and the nitrate will be double depending on the formula. Here sodium sulfate, also we see that sodium will be having double concentration and sulfate will be having the same concentration as the sodium sulfate. So we will see. So let's see the reaction. That's what I was telling you. We have lead nitrate. That means lead concentration will be equal to 2 times 10 power negative 3, but the nitrate will be double with this concentration because the dissociation will give 2 moles of nitrate. So the ion present, then you have lead which is equal to 2 times 10 power negative 3, but nitrate we need to double 4 times 10 power negative 3. We go again to the sodium sulfate, so we've produced 2 more of sodium and the sulfate, so that means the concentration of sodium will be double. So the sodium will be equal to 4 times 10 power negative 3, then the sulfate will be equal to 2 times 10 power negative 3 molar. So that was what they are asking. They are saying give the chemical equation for the reaction between lead nitrate and sodium sulfate. So then you can do the chemical reaction which will give the lead sulfate and the sodium nitrate. So this is the balanced chemical equation if the two they are going to react. Identify the ion that are most susceptible to form a precipitate when two solutions are mixed, and when two solutions are mixed, we will see that this is the precipitate which is going to be formed, and this information you get it from the solubility rules. We know the solubility rule that the lead sulfate is going to be soluble. So this is the precipitate which is going to be formed. Then they are saying if 1 liter of each solution, if 1 liter of each solution, if 1 liter of this one and 1 liter of this one are mixed, they're asking will a precipitate going to be formed? So they are giving the Chi-Sp. If we have the Chi-Sp of lead sulfate, so that means we need to determine the concentration for lead sulfate before mixing, the concentration of lead before mixing, and the concentration of sulfate before mixing, so that we can calculate the ionic product. Then from that, after getting the concentration of lead before mixing, the concentration of the sulfate before mixing we have, then we can also determine their moles. After determining their moles, then once we know their moles, then we determine their concentration after mixing. Because the concentration of lead and the concentration of sulfate after mixing, they are the one giving the ionic product. After getting the ionic product, then you compare it with Chi-Sp to determine whether precipitate will be formed or not. So let's see how do we get the concentration, the moles of lead and also the moles of sulfate. So we can get the moles of lead here because they are saying it's 1 liter. If we can take 1 liter because concentration is the volume, we get the moles. That means we get the moles of lead before mixing. Then so we have this one, the ion which are mostly going to form the precipitate is this one and this one. Then let's determine if the precipitate is going to be formed. So we have more of lead before mixing, so times 1 liter, then we get this more. We determine the more of sulfate before mixing. Also we multiply the with the volume, constant times volume, you get the moles. After getting the mole, then determine the concentration after mixing. But means we determine the total volume. Total volume will be equal to 2 liters. Then to get the concentration, we take the moles over the volume, which is 2 liters. Then you determine the concentration. Read after mixing, we get this one is 0.001. We determine also the concentration of sulfate after mixing by taking the moles dividing with the total volume, you get 0.001 molar. Then we just see how the equilibrium is going to be happening. We have read sulfate, which give read plus sulfate. In this case, then we determine the ionic product. So we multiply their concentration, we get this one as ionic product. Then we compare the ionic product with the KSP. We see that the ionic product is higher than the KSP. Here, a precipitate is going to be formed. So the ionic product is higher than the KSP. A precipitate will be formed. So with this kind of question, when you are asked to determine whether a precipitate is going to be formed, just determine the moles of each ion before mixing, then determine the concentration of each ion after mixing, then multiply the two concentrations to get the ionic product. After getting ionic product, you compare it with the KSP so that you can conclude whether the precipitate is going to be formed or not. So that was question number 13. Then we move to question number 14. So if we have determined the whether the precipitate is going to be formed, then we have another question, which is question number 14. Question number 14 is saying a solution was found to contain 0.1 molar of calcium ion and 0.1 molar of hydroxide ion. It's a solution which has a calcium ion and the hydroxide ion, which are the two ions. Then they are saying what is the equilibrium state of this solution with respect to calcium hydroxide. That means the two ions, they will form calcium hydroxide, and if the two ions, they are going to form calcium hydroxide, then in this case, if they are saying the state, a state with respect to calcium hydroxide, they are asking, is it a saturated solution, is it a supersaturated solution, or unsaturated solution? So that's what they are asking. So, and to know this kind of information, whether a solution is saturated, supersaturated, or unsaturated, we should also have the KSP. The KSP, of course, what was given, the KSP of calcium hydroxide was given. Then you can calculate the ionic product. Then you compare it with the KSP to see whether a solution will be unsaturated or saturated. So now they are asking what will happen to the solution if more calcium hydroxide is added. Of course, if you add more calcium, you end up with a precipitate. Then an equilibrium will be established so that we get an equilibrium. But let's see in which state you are going to see the solution, which has 0.1 molar calcium ion and 0.1 molar hydroxide ion. So we need to determine whether you have unsaturated, saturated, and supersaturated. If ions product is smaller than the solubility product, then the system is not at equilibrium, and the solid can be present. Such solution is said to be unsaturated because the ionic product is less than the KSP. So then, when a KSP is when the ionic product is higher than KSP, in that case we are having a supersaturated solution, which is ionic product which is higher than the KSP. So a supersaturated solution is not at equilibrium. If now we have a supersaturated solution, that means in some case the excess ion will precipitate until the solution is going to reach the equilibrium. So we have then the ionic product. So the ionic product for calcium hydroxide. So we have 2 molar of calcium. So then we replace the concentration, we get this ionic product. So we compare the ionic product with the KSP. We see that the ionic product is higher than the KSP. That means here the state of the solution is supersaturated because the ionic product is higher than our KSP. So then they are asking what will happen if the solution is not at equilibrium. That means then we have a precipitate which is going to be formed until equilibrium is going to be established. So if you add more, then if you have more calcium hydroxide which is added, that means the solution we will be precipitating until equilibrium is reached. So the solution will precipitate, forming more solid. So to decrease the concentration in solution until the equilibrium is established. So that was question number 14. Let's quickly move to question number 15. Question number 15 is saying we have a question where we have 10 milliliter of 0.02 molar sodium sulfate, which is added to 100 milliliter of 3.2 times 10 power negative 4 molar of barium chloride. The solubility product constant of barium sulfate was given. Now they are asking if a precipitate is going to be formed. So here again we have we have barium sulfate. The solubility product of barium sulfate is going to be formed. It was given. Now we need to check whether a precipitate is going to be formed. To check whether a precipitate is going to be formed, we need to determine the concentration of barium after mixing, the concentration of sulfate after mixing. Then we multiply the two concentrations to get the ionic product. Then after getting the ionic product, we compare it with the Chi-Sp that was given. If the ionic product is higher than the Chi-Sp, then a precipitate is going to be formed. Then how do you get the concentration of barium and the concentration of sulfate after mixing? So we need to get the number of mole before mixing. We have 10 milliliter of this one. If you multiply this one from here, we get the sulfate concentration by multiplying the volume with the concentration. And here we get the barium concentration, the moles of barium. Here also you get the moles of barium. Here also you get the mole. Here from this one, 10 milliliter times this one, you get the moles of sulfate. And here we get the moles of barium by multiplying the volume with the concentration. Then after getting the moles of sulfate and the mole of barium before mixing, then you determine their concentration after mixing. Let's see the concentration of barium before mixing. How do we get it? We get it from here, the concentration of barium before mixing. So we get 3.2 times 10 power negative 4. It was given. Then we have concentration of sulfate before mixing. Also we have it. Then let's look for the mole of barium before mixing. You take the molarity times the volume, then you get this moles. So that means we also determine the mole of sulfate before mixing. Then you determine the concentration of barium after mixing. After mixing means we divide it with the total volume. Then also concentration of the sulfate after mixing, we divide it with the total volume. Then we determine the ionic product. So we multiply this one, the ionic product, that we multiply the concentration. Then we compare the ionic product with a Chi-Sp. We see that the ionic product will be higher than the Chi-Sp. In this case, a precipitate is going to be formed. The precipitate will form. So let's go to question number 16. Question number 16 is saying we have 7.8 grams of calcium fluoride, which is dissolved in 100 milliliter of water at this 25 degrees Celsius. They're asking will a precipitate be formed. The Chi-Sp of calcium fluoride was given. So the logic is the same here. We determine the number of moles of calcium fluoride. Then after getting the number of moles, then we determine the concentration. So after determining the concentration, then you determine the concentration of calcium and the concentration of fluoride. Then you multiply them to get the ionic product, and then you compare it with Chi-Sp to determine whether a precipitate is going to be formed. Here we have the mass of calcium fluoride. We divide it with the molar mass to get the moles. After getting the moles, then we can divide it with the volume of water so that we get the concentration of calcium fluoride. We have the molar mass, we get the moles, get the concentration of calcium fluoride, which is equal to 1 molar. After getting the concentration, you can determine the concentration of calcium and the concentration of fluoride. That means the concentration of fluoride will be double because they have 2 fluoride, that means 2 moles. Then after getting the concentration of calcium and fluoride, you multiply them to get the ionic product. Then you compare it with the Chi-Sp. Then you see that the ionic product is higher than the Chi-Sp. Therefore, a precipitate will form. That was question 16. Question 17. Question 17 is saying how many precipitate will form? How many precipitate will form if 25 milliliter of 7.5 times 10 power negative 2 molar magnesium sulfate is mixed with 3.8 times 10 power negative 2 molar strontium hydroxide. The Ksp of magnesium hydroxide was given and the Ksp of strontium sulfate was given. Here you have the 2 Ksp and we need to determine whether two precipitate is going to be formed or not, because you have 2 Ksp. Then we need to determine, we need to calculate the 2 ionic product, and then you compare the 2 ionic product together with the given Ksp, so that you can determine whether 2 precipitate will form or if 1 precipitate is going to be formed. Of course, the logic is the same. From here, we determine the moles of magnesium and the mole of sulfate. Here also we determine the mole of strontium and the mole of hydroxide. Then after determining the mole before mixing, we determine their concentration after mixing by dividing the total volume. Then after getting them, we determine the solubility product. So that means determine whether this one is the precipitate is going to be formed or this one also is going to be formed. So sulfate are soluble, so that means strontium, so you can get strontium. Also here also magnesium also is a precipitate is going to be likely to be formed, but we need to confirm whether the 2 precipitates are going to be formed by comparing the ionic product with the Ksp. So we need to check if the 2 precipitates will be formed by comparing the ionic product with the Ksp. So we have here the magnesium sulfate. We have also the strontium, which gives strontium 2 plus 2 mole of hydroxide. Then we determine the mole of magnesium before mixing. We get the moles. We have the mole of magnesium and the mole of sulfate before mixing, of course. We determine the after mixing. So the magnesium, the concentration of magnesium will be equal to the concentration of sulfate. That means because here the magnesium, the mole of magnesium, we have this one is equal to the mole of sulfate also is equal to this one. So in this case, then we can determine the concentration after mixing. We see that we are going to divide it with the total volume. Then we have also we determine the moles of strontium hydroxide. So it's also the same. We get the after mixing, we get the concentration of the strontium. Then we have the concentration by dividing. We get the concentration, of course, by dividing with the total volume. So now we have the concentration of strontium after mixing. We have also the concentration of magnesium and sulfate after mixing. So we determine also the concentration of hydroxide after mixing. Also, we get this one. Then after getting the 2, then you can calculate the ionic product. Ionic product for magnesium hydroxide, that means magnesium times the OH, conserve OH. There is the power of 2 because the dissociation of magnesium hydroxide will give 2 more of OH. So we calculate the ionic product for magnesium hydroxide, we get this one. We calculate also the ionic product for strontium sulfate, also we multiply their concentration, we get this one. Then after we compare the ionic product with the Ksp, we see that magnesium hydroxide will form a precipitate. Again, if you compare also for strontium, also we see that strontium sulfate will form a precipitate. That means we have 2 precipitates which is going to be formed, which are going to be formed. So the 2 precipitates are going to be formed. Question number 18, they are asking a solution is 1.5 times 10 power negative 6 molar in NiCa 2 plus, that means the ion sodium carbonate is added to make the solution 6 times 10 power negative 4 molar in carbonates. That means here we have they have added this one so that they get this concentration of carbonate. So they are asking the Ksp of NiCa carbonate was given. They are asking if the NiCa carbonate will precipitate. So here again we need to see. We have the concentration of NiCa and we have the carbonate. We can determine the ionic product. Then after getting the ionic product, then we compare with the Ksp. So we determine the ionic product. Then after determine the ionic product, we can see that the ionic product 9 times 10 power negative 10 is less than the Ksp, the given Ksp. Here that means because the ionic product is less than the Ksp, here we don't form a precipitate. So you will see that because ionic product is less than the KSP, no precipitate will be formed. That was question 18. Let's go to question 19. Question 19 is saying 0.5 liter of 1 times 10 power negative 5 molar of lead acetate was combined with 0.5 liter of this concentrated potassium chromate. They are asking if a precipitate will occur. Here again, they are giving the KSP, then they are saying find the equilibrium concentration of lead remaining in the solution after the lead chromate precipitate. Here they are bringing a new concept. If now a precipitate is going to be formed, what will be the concentration that will be remaining into the solution? Because if you have a precipitate which is formed, that means a solution will precipitate by decreasing the concentration of the ions into the solution until the equilibrium is established. Now they are asking what will be the concentration of lead when that equilibrium is going to be established. That is 2, but the first one they are asking if a precipitate is going to be formed. So that means we need to determine the concentration of lead after mixing, the concentration of chromate after mixing. Then we calculate the ionic product and then we compare with KSP. Then we get whether a precipitate is going to be formed or not. So let's first determine the mole of lead from here, from this one, and the mole of chromate from this one. Then after getting the moles before mixing, then you can determine the concentration after mixing by dividing the total volume. So we have this one, lead chromate, the solid which is going to be formed. We need to calculate the ionic product for lead chromate and then compare it with the KSP. For this, we need the concentration of lead and the concentration of chromate after mixing. So let's determine the concentration. So we have the moles of lead before mixing. So we have it. Then we determine the moles of chromate. So before mixing, so we have the moles of lead before mixing and the mole of chromate before mixing. Then we determine their concentration by dividing with the total volume. So here, how do we determine the mole of lead before mixing? That means take the volume times the concentration, 0.5 times the concentration. It's very simple. Then after getting the moles of chromate and the moles of lead before mixing, then you can determine their concentration by dividing with the total volume. Concentration of lead after mixing, we get this one, so we are dividing with the total volume. The total volume is 1 liter. Concentration of chromate after mixing, we divide with the total volume, we get this one. Then we determine the ionic product by multiplying the 2. So the ionic product, this one, then we get 2.5 times 10 power negative 9. We see that the ionic product is higher than the KSP. Here a precipitate will be formed. But if a precipitate is going to be formed, what will be the concentration that will be remaining to the solution? The concentration of lead that will remain to the solution. Here then we need to see a new equilibrium. Precipitation of solid can shift the equilibrium of a reaction occurring in the solution. If we have a precipitation, it will shift the equilibrium. That means the precipitate which is going to be formed, the precipitate is going to be formed, and it is decreasing the concentration into the solution until the equilibrium is going to be established. A new equilibrium will be established. So here then we know we need to determine how much of lead and how much chromate will react to form the precipitate. That means the one which will remain in the solution will be the excess. But we need to determine if now I am forming a precipitate, which one is going to be remaining in the solution and which one is going to form a precipitate. So here then, so we have the concentration of lead and you have the concentration of chromate. So if you check this concentration, so we will see that this concentration of lead is the one which will be less. And we have the high amount of concentration of chromate. So, and if you check the reaction, they react with 1 mole of lead, you react with 1 mole of chromate. That means this concentration, 5 times 10 power negative 6, we react with 5 power 10 power negative 6 of chromate. So that means we'll be having 1 in excess. That means we have chromate that will be in excess, because here we have the concentration of lead which is less as compared to the concentration of chromate, and the reaction is react 1 mole with react of lead reacting 1 mole of chromate. So that means here we'll be having the excess chromate ion. How much of excess we need to calculate by taking this one minus this one to get the excess chromium that will be left into the solution. So we'll be having the mass of chromate not forming a precipitate, will be having the subtracting to get the mole of chromate not forming a precipitate. So now we have a precipitate which is formed, and you have another ion which is chromate which is in the solution. That will form a new equilibrium. A new equilibrium will be established. So let's see. So we have seen we have in a mixture we have lead chromate which is a solid which is a precipitate. We'll be having the lead 2 plus because it will remain as 0 because it will all form with lead solid, lead chromate as solid. We have also the chromate which will be remaining into the solution. That will be the initial half. Now the equilibrium is going to be established. If equilibrium, the change, initial change, here we have the x, here we also have x which will be formed, and here a initial change equilibrium. At equilibrium here we will be having 0 plus x, we got x, here we have the x plus this one. So then we just determine the Ksp, which will be equal to x times this one. Of course, because this x will be negligible because we are having the common ion effect. We have the chromium already present in the solution, so this x can be negligible. So here we have the reaction that will be here the Ksp, we know it, then we can determine the x. X will be the concentration that will remain in the solution at equilibrium, will be equal to 3.64 times 10 power negative 11 more. If we want to determine the concentration of chromate at equilibrium, then we take x plus this amount so that you can get the concentration of chromate at equilibrium. Let's go to question number 20. So what you need to know is that after forming a precipitate, a new equilibrium will be established by a precipitate together with the remaining ion in equilibrium. The remaining ion after forming the precipitate, a new equilibrium will be established. They will form a new equilibrium. A precipitate and the excess ion after forming a precipitate, they will form a new equilibrium. So question number 20 is saying a 25 milliliter of sample of 0.05 molar of silver nitrate is added to 50 milliliter of sodium iodate. Determine the initial concentration of silver and the iodate. So here, to determine the initial concentration, here you have this one. Silver will be equal to this one, and then the iodate also we have this concentration. With the silver iodate precipitate, so they are given the Ksp, determine the equilibrium concentration of silver plus and the iodate. So here then we need to determine the ionic product. We compare with Ksp, and then we determine the concentration at equilibrium. After finding that the precipitate is going to be formed. So we have a concentration before mixing. Then we get before mixing, we consider each compound separately to calculate the concentration for ions. Then concentration after mixing, we consider the total volume. So the volume increased and the concentration ion are decreased. Consider the total volume. So we calculate the ionic product. After calculating the ionic product, then we determine the concentration when equilibrium is established, because the precipitate is going to be formed, and the precipitate together with the ion that will remain into the solution, they will form a new equilibrium, and then we determine the concentration at equilibrium. So that's what we'll be dealing with. Let's first see the 25 milliliter of silver nitrate. We have the concentration of the silver, and here we get the concentration of iodate. So this one. So after getting them, so we get also the Ksp. We calculate the ionic product. So we have the mole of silver before mixing. We take the concentration times the volume. Then we determine the mole of iodate before mixing. Also get the moles. After getting the mole, we determine their concentration after mixing by dividing with the total volume. We get this one for the silver. We get this one for iodate. We calculate the ionic product. So by multiplying the two, we get this one. We compare the ionic product with the Ksp. We see that the precipitate will form. So after getting the precipitate, now we see which ion is going to be remain to the solution after forming a precipitate. So we get here this concentration. So we can see that the iodate concentration is higher and the silver concentration will be small. So that means we get iodate concentration in excess. We calculate how much excess of this iodate concentration. Silver iodate, we continue to precipitate until the system reaches equilibrium. So then here we do the new equilibrium. So we see that the excess iodate remaining, we take this one minus this one, then we get this one. That means this is the concentration of iodate that will be remaining the solution together with the precipitate. Then we form a new equilibrium with this concentration of excess iodate together with the precipitate, which form, they will again form equilibrium. So they will try to form the equilibrium. So after forming the equilibrium, then we get this is the precipitate which is formed. The silver will be 0, then the excess, then you have the change x, then you have the equilibrium, then you get thing x plus this one, then we have the Ksp. Then we consider this one is negligible because you have the common ion effect, the iodate that will be in equilibrium, that will be in excess. Then we determine the concentration of X will be the concentration of silver, so that means the concentration of silver will be this one at equilibrium. Then we determine the concentration of iodate at equilibrium by taking the X plus this one. Then you get this one as the iodate at equilibrium. So that is what was the package of today. That was the package of today. So hope that you have managed to calculate the whether a precipitate is going to be formed or not. So next time we will see the selective precipitation, the calculation involving selective precipitation. So have a good weekend.